Hi students, welcome to the Engineering Geology Laboratory session. I am Shiv Kumar. So in the Engineering Geology Laboratory subject contains 9 experiments including Viva voice. The number 1 is identification of rocks, number 2 identification of minerals, number 3 determination of thickness of strata, number 4 determination of dip and strike, number 5 borehole problems, number 6 interpretation of geological maps, number 7 interpretation of topographical maps, number 8 resistivity curve interpretation, number 9 Viva voice. Here the number 3 and the number 8 is optional. You can do it the determination of thickness of strata, or you can go it for resistivity curve interpretation. Now I am going to explain you about the experiment number 3, that is the determination of thickness of strata. Determination of thickness of strata. So what do you mean by strata? The strata means the rock bed. So if you see below the surface of the earth, the rocks will deposit in the form of layers or the beds. So this beds, the single individual bed is termed as in strata. Now in this method we are going to learn about how to determine the exact thickness of this individual bed which is lying below the surface. So here when we are talking about the thickness, in this experiment we have two types of thickness. That is, one is vertical thickness, number 2 true thickness. Along with that vertical thickness and true thickness, we need to determine two more parameters. It is called width of outcrop and the dip of the strata. Now let us understand all these 4 parameters and how we are going to determine them. First of all, as we know, the rock beds below the surface will not present always in a horizontal position. So in few cases the rock beds may be inclined or tilted also. So this is scenario number 1 where the rock beds are deposited in horizontal position, and this is scenario number 2 where the rock bed is deposited in inclined position. So now let us know one by one. So let us know what is in the outcrop. So here in case of inclined position, the rock beds which is exposed onto the surface, it means some part of this rock bed will be exposed above the surface, and this exposed part is called as an outcrop, and the width of this exposed part is called as width of outcrop. So this is the first parameter which we are going to determine, the width of outcrop. The number 2, we have dip of the strata. Dip means here the inclination of the rock strata with respect to the horizontal plane is called the dip of the strata. This is number 2. Now we need to know what is the difference between vertical thickness and the true thickness. The vertical thickness is that which is measured always vertically downwards from the surface. That is, it is always measured perpendicular to the surface line. Perpendicular to the surface line. So this is the VT, means vertical thickness of the bed. Next we have a true thickness. True thickness is that which is measured perpendicular to the bedding planes. So what are bedding planes? So if we are considering this as a bed, the upper part of the bed is called as an upper bedding plane, and the lower part of the bed is called as an lower bedding plane. So with the help of these two bedding planes, we are going to determine the true thickness. That is, when we are measuring perpendicular to these bedding planes, that gives us the true thickness. So that is the exact thickness of the rock bed. So now in the case of this horizontal position of the bed, this vertical thickness and true thickness both are same because the bed is lying in horizontal position. So both the measurements, the vertical thickness and the true thickness measurement, will be same in case of horizontal beds. Now when coming to the scenario 2, that is when the inclined beds, the vertical thickness and the true thickness will differ here. Now how we are going to measure the vertical thickness? Vertical thickness is always measured perpendicular to the surface line. Now so this is our VT, that is vertical thickness, which we are measuring vertically downwards from the surface. And how to measure the true thickness now? True thickness we are going to measure perpendicular to the bedding plane. So this is in lower bedding plane and this is upper bedding plane. So perpendicular to these bedding planes we will get the true thickness. Now here the length of the true thickness is less than the vertical thickness because the bed is in the inclined position, so the vertical thickness will be increased. So these are the 4 parameters which we are going to determine in this experiment. It is width of outcrop, that is the rock part. Outcrop means the rock part which is exposed onto the surface is called outcrop, and the width of that when we are measuring, that is called width of outcrop. That is the number 1 parameter. And the inclination of the bed with respect to the horizontal surface is called dip, that is the second parameter. And the vertical thickness which is always measured perpendicular to the surface line, that is called vertical thickness. And true thickness which is always measured perpendicular to the bedding planes. Now let's start doing the problems. So here the problem number 1 is given. A sandstone bed is exposed on the surface. Its width of outcrop, WOC means width of outcrop, is measured 360 meters and dip is 30 degrees west. Determine its true thickness and vertical thickness. So now in this problem they have given some values, that is they have given width of outcrop and dip value, and with the help of that we need to determine the true thickness and the vertical thickness. Now to solve the problem, first what we need to do is we need to take the given data. So what is the given here is WOC, that is width of outcrop is given, that is 360 meters. Dip is given, it's 30 degrees west. And what we need to determine is true thickness and vertical thickness. So this experiment should be solved in 2 methods. One in geometrical method, and number 2 is mathematical method. First let us solve through the geometrical method and let's move on to the mathematical method. So to solve in the geometrical method we need scale, protractor for that. Now let's start doing the problem. First draw a horizontal line. There is no exact measurement for this. It's in you can draw it for any measurement. To draw one horizontal line and mark the directions. Always east will be towards right and west will be towards your left. Now this is considered as a surface line. So on this surface line we need to mark the parameters which they have been provided in the problem. So they have been provided two parameters, that is WOC and dip, width of outcrop and dip. So now let's start marking these parameters one by one on this surface line. So first we will mark the WOC, that is width of outcrop. Now on this surface line, mark one point anywhere on the surface line, mark it as an A. Now to mark this width of outcrop on this surface line, we need to convert these meters to the scale. So I will take scale as 1 centimeter is equal 100 meters. Now when we convert these meters into this with this scale, so 360 meters will be converted to 3.6 centimeters. So I will mark this 3.6 centimeters on this surface line. So we will place the scale on the point A on the surface line and I will mark exactly 3.6 centimeters. 1 2 3 3.6, exactly 3.6 centimeters, and I will mark that point as in B. So this is width of outcrop. So now we have marked the first parameter successfully. The next we have the dip of the bed. So dip of the bed is given 30 degrees west. Now use your protractor and place it on any one of the point A or B. I will place it on the point A like this. Our zero should coincide with the surface line and I am placing the center point exactly on the point A. Now we should measure 30 degrees towards west. See, this is our east and this is our west. So we need to measure towards the west. So 30 degrees. So here this is our 0, 10, 20 and 30. So this is 30 degrees and I will mark this point as in C. So now I will join A and C. So this is the upper bedding plane. Now this angle will get 30 degrees. So in the same way we need to mark it for the point B. In the same way I will place the protractor on the point B and I will mark 30 degrees towards west and I will mark it as in D and I will join BD, so where we will get the lower bedding plane. So now this is the lower bedding plane. Now we have marked the dip also on the diagram. So now with the help of this we need to determine the true thickness and the vertical thickness. So here how we are going to measure the vertical thickness? As I said, vertical thickness is always measured perpendicular to the surface line. It is vertically downward from the surface. So that should encounter both the bedding plane. So from this point, from the point A, I will draw one vertical line till the lower bedding plane. So this is our VT. So let us measure the length of that. So this is exactly 2.1 centimeters. 2.1 centimeter. So VT we got as 2.1 centimeter. Now we need to determine TT, that is true thickness. So how we are going to determine the true thickness? So the true thickness is always measured perpendicular to the bedding plane. So these are the two bedding planes what we have. So we can mark any point on these lines and we can draw one perpendicular line that gives us the true thickness. So I will take from the point A itself. So I will again, to get the perpendicular line, I will use protractor and I will place it, my protractor, on the point A and coinciding the 0 with the upper bedding plane the same way. So now I will mark exactly 90 degrees to get a perpendicular line to this bedding plane. So now I will draw line here and I will stop that line at the point of lower bedding plane. So now this is our TT, true thickness. So let us measure the length of that. So here we have 1.8 centimeters. So true thickness is measured 1.8 centimeters. Now let us convert this scale into meters. Again, 2.1 centimeters means, as per the scale, it is 210 meters. 1.8 centimeters is 180 meters. As we have taken 1 centimeter is equal to 100 meters. So when we are converting these centimeters into the meters, we will get 180 meters and 210 meters. So this is how we are going to determine the vertical thickness and true thickness of the bed in geometrical method. Now let's solve this through the mathematical method. In the mathematical method, we need to use the formulas to determine the true thickness and vertical thickness. And what we need to remember is, we should not consider these values when we are determining through the mathematical method. So whatever the values given in the problem, by using that values, we need to determine the vertical thickness and true thickness. And for that, we have a formula for determining vertical thickness, that is tan theta into WOC, that is width of outcrop. Theta is the dip value which is provided in the problem. Now you can see tan of theta is what? The dip angle which is provided, that is 30 degrees they have provided. So tan of 30 into WOC is also given, that is 360 meters. 360 meters. We should not take 3.6 centimeters here, we should take in meters. So now calculating this tan 30 into 360, you will get 207.8 meters. So this is our VT which we got through the mathematical method. Now for TT, we have a formula, sin theta into WOC. Sin of theta is again dip, that is 30 degrees, into width of outcrop, that is 360 meters. So you will get 180 meters. So this is the TT value we got through the mathematical method. So this is how we are going to do the thickness of strata problems by geometrical method and as well as in the mathematical method. Now let us try to solve one more problem. So here the problem is given: a limestone bed is exposed on the surface, its width of outcrop is measured 240 meters and its vertical thickness is 160 meters. Determine its dip and strike. The limestone bed is exposed on the surface, its width of outcrop is measured 240 meters and its vertical thickness is 160 meters. Determine its dip and true thickness. So in this problem, they had given width of outcrop and the vertical thickness, whereas in the previous problem they had given width of outcrop and dip, and they asked us to determine the true thickness and vertical thickness, where here we need to determine dip and true thickness. So first let us take what is the given data. So given WOC is 240 meters and vertical thickness is given 160 meters, and what we need to determine is theta, that is dip and true thickness. The first what we need to do is we need to convert this into scale. Here I will take scale 1 centimeter equal 50 meters. So no problem, you can take 1 centimeter is equal to 100 meters also, as I have taken in the previous problem, and here the values are less. To get the bigger picture I am taking the lesser scale. So now converting this 240 meters into the scale, I will get 4.8 centimeters, here 3.2 centimeters. Now let's solve in geometrical method first. For that, I just draw a horizontal line, mark the directions, and WOC is given. Let us mark the WOC on the surface line. So for that we will mark one point, so mark it as an A, and the WOC is given 4.8 centimeters. So I will mark exactly 4.8 centimeters on the surface line, and I will mark this point as B. So this is our width of outcrop, 4.8 centimeters. Now then given the vertical thickness. So vertical thickness should be marked here. So how to mark the vertical thickness? Again, perpendicular to the surface line, vertically downwards, 3.2 centimeters. So we will use our scale and I will place it on the point B, and I will mark exactly 3.2 centimeters. 1, 2, 3.2 centimeters, and I will mark this point as C. Now I will draw a line and I will join B and C. So this is VT, 3.2 centimeters. So this is the given values, and with the help of this we need to determine the dip and TT. So for that we need to get the bedding planes to determine TT and dip. So what I will do is I will join A and C, the point A and C, so that I will get a bedding plane. So this is our lower bedding plane. So now I will measure the dip using the protractor. I will place my protractor on the point A. So the 0 is coincide with the surface line, and I will measure the amount of inclination, that is the dip here. So 10, 20, 30.4, 34 degrees. So the dip is 34 degrees. Okay. Now for the same measurement I will mark a point on the point B to get the upper bedding plane. So I will place the protractor on the point B and the same measurement, that is 34 degrees. Here this is 0, 10, 20, 30, 30.4. Now I will join this. So we'll get the upper bedding plane. So now we determine the dip. Now we need to determine the true thickness. So how to measure the true thickness? True thickness is always measured perpendicular to the bedding planes. Now we got the bedding planes. We have lower bedding plane and upper bedding plane. So let's start measuring the true thickness. I will use again the protractor. I will place at the point B, and the 0 of the protractor is coincided with the upper bedding plane here. Now I will mark exactly 90 degrees to get the perpendicular line to this upper bedding plane. Now with the help of the scale I will draw a line. So this is the 90-degree point, and I will draw a line and I will stop it at the point of lower bending plane. So this is our TT. So let us measure the length of this. So we got 2.7 centimeters. So now here we got dip 34 degrees and TT, that is true thickness, is 2.7 centimeters. When we convert this 2.7 centimeters into the scale, we will get 135 meters. As we have taken 1 centimeter is equals 50 meter scale, so this will be converted into scale, meters. So 2.7 centimeters will become 135 meters. So this we have solved through the geometrical method. Now let us do it in the mathematical method. As I said, while solving through the mathematical method, we should not use these values which have been determined from the geometrical method. So we should use always the values which is given in the problem. So here Vt is given. So by using the Vt and Woc values, we will determine the theta value, that is the dip value. So Vt formula, Vt is equal tan theta into Woc. So now we need theta value. So Vt is already given, that is 160. Woc is given 240. So now 160 by 240 will get, so theta, so tan inverse of 666. So we will get theta equals 34 degrees. So this is the value which we got through the mathematical method. Now to find out the TT is equal sin theta into Woc. So sin of theta value we have already got, that is 34, into Woc is already given 240. Now TT we got 134.2 meters. So this is the values which we got through the mathematical method, and this is the value which we got from the geometrical method. And this is how we are going to do the determination of thickness of strata problems. So let us solve one more problem with different parameters. Again, here the problem is given: a grey is exposed on the surface where its dip is measured 35 degrees east and its true thickness is 180 meters. Determine its Woc and Vt. So this is a different problem from the previous problems. Here they have given dip and true thickness, where we need to measure the Woc, that is width of outcrop, and vertical thickness. Let us take the given data. Given dip they have given, that is 35 degrees east. True thickness is given 180 meters, and we need to determine Vt and width of outcrop. So we will convert these meters into the scale first. We will take scale as 1 centimeter is equals 50 meters. Now this will become 3.6 centimeters. Now let us do it in the geometrical method first. Let's draw one horizontal line, mark the directions, and let us mark these parameters one by one. Let's mark the dip first. To mark the dip, we will mark any one point on the surface line. From this point I will mark 35 degrees towards the east direction. So I will place my protractor on this point A. So my 0 is coincided with the surface line. So 35 degrees towards the east. So this is 0, 10, 20, 30, exactly 35 degrees. So we'll mark this point as C. So I will join this A and C. So I will get the bedding plane. So here this is 35 degrees. So we have marked the dip on the surface line, and we need to mark the true thickness. How to mark the true thickness? True thickness is always measured perpendicular to the bedding plane. So true thickness we have 3.6 centimeters. So that to mark perpendicular to this bedding plane, so this is the upper bedding plane. So perpendicularly to this bedding plane we need to draw the true thickness line. So for that I will place again my protractor on the point A, and the 0 is coincided with the bedding plane here. So my center point is at the point A on the surface line. So I will mark 90 degrees exactly, and I will mark this as D, and I will draw a line joining A and D, but we should draw a line to this measurement exactly, that is 3.6 centimeters. So 1, 2, 3.6 centimeters. So I will draw exactly 3.6 centimeters line. So this is the TT, that is 3.6 centimeters. So now to get the lower bedding plane, I will use the same line at some other point in this bedding plane. I will mark one more point on this line. I am using this point to draw a parallel line of upper bedding plane to get the lower bedding plane. So I will place protractor on that point, and again I will mark 90 degrees, and I will use the same measurement here again, that is 3.6 centimeter. So here we have 3.6, again 3.6. Now joining these 2 points we will get the lower bedding plane. So this is the lower bedding plane. So I will extend this line upwards, and I will draw the surface line that should intersect with this lower bedding plane. Now this point is marked as B. Now we need to measure the width of outcrop where we got the 2 bedding planes here. So measure the distance between A and B, we will get the width of outcrop. So that is 1, 2, 3, 4, 5, 6.3 centimeters. So the width of outcrop is 6.3 centimeters. 6.3 centimeters. Now we need to measure the vertical thickness. So measuring vertical thickness is very simple. Measuring vertically downwards from the surface line, that is perpendicular to the surface line. I will draw a vertical line here. So this is my VT. So let us measure the length of this. 1, 2, 3, 4.6. 4.6 centimeters. So we got VT 4.6 centimeters, WOC 6.3 centimeters. When we converting into this scale into meters, so 4.6 when we are converting to meters, we get 230 meters, and here this will come 315 meters. So this is the values